Hi everyone. So in this video also we are going to continue the paging concept and segmentation also. We are going to discuss about what is segmentation, right? Okay. So page table and segment table. So if you are considering that contiguous memory have difficulties, that is internal fragmentation and external fragmentation. So we need to provide the solution for that internal fragmentation and external fragmentation. So that solution may be a paging and segmentation, and these two are comes under the non-contiguous memory allocation, right? Okay, so in the paging concept, your physical memory and the logical memory, right? Logical memory, it belongs to the process, right? Okay, your logical memory will be divided into a number of pages, right? Okay, and your physical memory will be divided into number of frames, right? Okay, and same one here, the size of the page equivalent to size of the frame, right? Size of the page and size of the frame, both are equal, right? Okay, so now you need to understand that in any process execution, your CPU will generate the address. So CPU will generate the logical address, right? Your CPU will generate the logical address, right? And here whatever is there inside the physical memory, that is called your physical address, right? This is logical address, right? Okay, so this is the combination. Now what will be there? Every process will be represented in the form of page table. Page table is required for every process, right? So page table will have number of entries. So one will be the page number. Page number will be there in the page table, right? Another one is the frame number. Or you can say, so but if you are saying that logical address, how logical address will be generated? So logical address will have the combination of page number and page offset. This will be the combination for logical address. Now how the page number will be mapped with the physical frame, right? Okay, so here example, if the process requires page table is page numbers are 0, 1 and 2, right? Okay, so the frame number, because here you need to understand that anywhere if the free frame is there, so there the page will be available, right? So example, the frame number may be 3 and here it may be 5, again it may be 1, like that, right? Example, if you're saying that here the page number, here this is the page number 2, right? And this is the page number 0, and this is the page number 1, right? This is how entry is there. Now if during the execution, so the logical address will be generated, the page number will come, and the logical address, the page number will be verified that where in the page table entry page number is there or not, right? The page number is there. So along with that, it verifies that where is the frame number. So frame number will be verified inside the frame. So what is the meaning of page offset? Inside the frame, which byte you are going to access, right? And a page is the combination, because page size equal to frame size. So page is example, it may be 4 MB or 2 MB, something like that. So inside the page, which byte you are going to access, that is called page offset. Here page number will be identified, then frame number will be identified. Now how the physical address will be generated? Here frame number and frame offset, right? The frame offset is equal to page offset. So only the thing has changed is page number is converted into frame number, then frame number, frame offset. So example, if you are going to 0, then here you are accessing the 0. Inside 0, then which byte you are going to access. So this is how your page table entry will be there. This is how your paging works, right? Okay, so every process will represent the page table. Page table is a logical representation. Here the two entries will be there. Page number and the frame number will be there. The logical address will be generated by CPU that have page number and page offset. So through this logical address, you can find the page number and the frame number. Then offset will be directly connected to the physical address. Here the frame number will be taken, and here example, if I am saying the page offset is 2, and here this is the frame number and this is the offset number. Like that, here it will go, right? So it will go to the frame number 3 and it will access the third byte. So this is how your page table works. Then how it comes to the segmentation, right? Okay, here you need to understand that number of pages will be there. So your logical memory and the physical memory divided into equal sizes, right? Here pages and here frames will be there. And if you are coming to the segmentation, already we know that a program, a process is the execution of a program. So program have multiple segments. Segments means multiple models will be there. So code model will be there, then data model will be there, then file will be there, then subroutine inside the functions, right? Subroutines will be there. All these have different models will be there. And same time, all these models may not have in the same size. The size required memory size may be different. So your logical representation of a segment, you just consider this is the program, right? The program may have, this is maybe a code part, and this may be a data part, and this may be a function, that is subroutine part, and this may be a file, and this may be another segment. So now you just understand this is segment 1, and this is segment 2, and this is segment 3, and this is segment 4, and this is segment 5, right? Okay. But here the required memory space also different. So here it may require 200 memory locations, it may require 100 memory locations, and here the file part it may require 1000 memory locations, and it may require only 50 memory locations, likewise. And here, while you are going for the segmentation, again the process will be represented into the segment table concept. And here 3 entries will be there. One is a segment number will be there. Segment number will be there. And here the segment number will be 0, 1, 2, 3, something like that. And here the segment is called model, right? Some bunch of locations are required, right? Okay. So here the segment number will be there, and here base address will be there. Base address and limit address, right? So base address means, in this already I told you that the memory location may be occupied by the operating system, first part, and remaining, right, the segments will be there. So different sizes, whatever it is, may be there, right? Okay. So here for segment number 1, and here I am just changing that here, segment number 0 and 1 and 2 and 3 and 4, right? Okay. So here for my segment 0, my starting address may be 500. This is my base address, right? Then how many locations are required? 200. So my limit will be 200. So example 500 means, example I am saying that here it may be 100, and this may be 500, and this may be 700, and this may be 1700, right? And this may be example 1700, and here it may be 2300, something like that. Is it right? Okay. So now page table entry, how it will be? So here that this is my base address, right? This is my limit, right? So now if the process is executed, now it will come further. So now segment table, the segment number and the 3 entries will be there. Segment number will be there, base address and limit will be there. Now based on that, it will go to the segment number 0, then base address will be identified. So base address means it will go to the base address, right? So from this base address, how many locations will be allocated to, say, process 1? That's for, say, a segment 1. These 200 locations will be allocated, right? Here, what error may happen? Sometimes error may happen. So while you are entering, so actual segment, this is segment number 0, right? Okay. So in the segment number 0, the starting address is 500, limit is 700. Sometimes if you are checking that, while you are if error happened, this goes for 300, right? Now this address will be verified, right? Okay, segment number is right. Yes, segment number is right. And the offset, that is a D, right? Offset value is 200. So 200 need to be, so example, segment 0's D need to be less than or equal to actual size, right? This S0, right? Actual size, right? Then only it will be allocated. So only thing 200 or less than 200 only allocated to segment number 0, but the limit is 300. This limit may not suitable for segment number 0. So here error may happen, right? Now you need to understand that what is the major difference between this page table and the segment table, right? So page table entries, only 2 entries will be there. That is a page number and the frame number, right? The logical address may be generated by page number and the page offset, and here also segment number and segment offset, but 3 entries will be there here. So one will be the segment number, and here base address and the limit address will be there. Based on that you can find that how the logical address will be formed. Then you need to convert into a physical mapping, and here this will be the segment number will come, then which are the locations you can access, that is called limit, right? So segment always differs from the paging. Here all the example, your frame size and the page size equal, and here the segment may be number of segments. Your whole program will be divided into number of segments based on the requirement for coding. Some of the programs may have very less number, only 5 lines will be there. So your coding part locations will be very less. But some of the programs may have 1000 lines. Then your coding part model, that segment may be higher limit. So this is the major difference between page table and the segment table. And also this is the major difference between your paging and segmentation. Both the solutions comes under the non-contiguous memory allocation. Right? Thank you.